Hi, my name is Marcello Gonzalez, and I'm applying for the Mechatronics Engineering portion of GHP. Since the age of 5, I've had an interest in designing and building, but it was not until the age of 12 that mechanical engineering became my true passion. I've craved to both learn more and challenge my engineering skills through different engineering programs ever since. This is a wooden trebuchet that my team of 3 designed and built. The goal of this project was to construct a working trebuchet that would launch a ball at least 7 yards and on a separate test hit a box 5 yards away. We used the Google SketchUp design software to design and prototype the project, and from this design the final product was built. In the end, the trebuchet met both goals of hitting the box and launched past 7 yards. We all had equal participation in the design and construction. This is a mousetrap car that I built with a classmate in our engineering class. The goal of this project was to design, prototype, and make a small car that could roll 10 meters by the power of one mousetrap. I was responsible for designing the car and constructing the wheels and the mechanism that transfers the power of the mousetrap to the wheels. On the presentation day, our car reached 10 meters. This is a Vex robot that I built with a classmate in our engineering class. The goal of the project was to build and program a basic Vex robot using ECC coding to autonomously drive a stair pattern. I was responsible for programming the robot and constructing the drivetrain and the base of the chassis. The robot was able to travel most of the way, but not the whole way. This is a scale drawing of my television that I made in my drafting and design class. The goal of the project was to choose an object that could be scaled down to half of its original size on paper, and then to draft the object. Once the design was complete, we had to render the object on a design program called AutoCAD. In 11th grade, a classmate and I used the engineering design cycle to research parts of a glider, brainstorm 30 different glider designs, and prototype 3 preferred designs. The goal of this research was to make a glider that would carry an egg 65 feet unharmed. I built this balsa wood glider prototype, and while this is not the final product, it can carry an egg 65 feet unharmed. Now for some of my builds outside of school. I am in the center of this picture working on part of the wing of a Stonix aircraft at the Candler Airfield Youth Program. In this program, the students are mentored by professionals on how to build and fly different planes. Other projects that I have helped construct include an Aeronica Champ and a J3 Cub. During the summer of 2016, I went to a Civil Air Patrol camp called E-Tech Robotics in California. At this camp, we worked with LEGO Mindstorm EV3 Robotics to construct different structures and vehicles. We also learned how to program the robots and their different sensors, such as the color sensor, through the Mindstorm EV3 software to complete tasks either autonomously or by remote. Here are some examples of the robots that I helped create. This is a BattleBot that my team made. The point of this project was to create a robot that can compete against other BattleBots. My team decided on a ramp design for the body to trap speed-based robots, and we attempted to give the robot torque and power instead of speed through a 3-to-1 gear ratio. I helped build the chassis and part of the ramp. We won one battle and we finished in the final 3 during the battle against everyone. This is a robotic plane. The point of this project was to build a model plane and program it to have movable control surfaces, or rudder, ailerons, and elevators. I helped in the construction and gearing of the robots, and in the end, the plane performed well. This was a remote control car that my team made. The point of this project was to build a completely controllable car that could compete against others. Our team used only one motor to power the car, a pinwheel steering system, and a gear differential in the back. I helped build the chassis and the steering system. In the end, our car was the victor of each race that it competed in due to its quick acceleration. This was our final project at E-Tech. The goal of the final project was to create anything that we could think of, using what we learned during the week. My team decided on building an autonomous tank that would complete different actions when it sensed different colors through a color sensor. I built the chassis, the treads, and the drivetrain. In the end, the robot worked well, but because the color sensor only worked at a particular height, the tank did not perform well consistently. This is an autonomous crossbow launcher that I helped make for the annual RoboBoat competition during the summer of 2016 at Georgia Tech. The purpose of the crossbow was to autonomously launch a submersible with a built-in camera over a dock, so the camera could capture information placed both underneath and on the opposite side of the dock. I helped design the crossbow, and I helped build the ramp and bow arms. Out of the 2 groups that attended the program, the graduate students who were going to competition chose my team's crossbow over the other team's incomplete air cannon. In the end, the graduate team won first place.